that part of Canvas page. Okay, let's do it. What we will do. Okay, let's talk about the polar coordinates. I mean, first of all, polar coordinates are different than Cartesian coordinates. Yes, we know the Cartesian. Cartesian are just the straight lines, 90 degrees, like right angle. We will like get some like we will call X and Y. That's the really rough draft of the Cartesian plane, but we all know everything. We know the origin, 0, 0, 0, and then we're using just like the perpendicular distances. I mean, this will be distance actually 3, yes, from the 0, and then if we would like to get also the vertical distance, we will also go like with the what I'm saying with the straight lines, 1, 2, let's say. That means this is 3, 2. All right, that's when we can see everything. It's like we can't like turn, we will just go nicely like horizontally and vertically, just the right angles. But the polar coordinates are a little bit different. Right? We also have, I mean, we do have some not similarity, but we can make some connection, which we will, of course, we will do. We will connect Cartesian, X, Y, and we will connect the polar. So what we need for the polar coordinates, we also need some plane, polar plane, we will call, because we always need some reference point. Like for the Cartesian is 0.00 origin, and then the distance from 0 is 3 along the x. Distance from 0 is 2 along the y-axis, and so on. Yeah. So for the polar, we will need some reference point. The reference point will be placed in the polar plane, and I can maybe get this, let's say something like this, and I will draw it, okay? And I can call O. So we will kind of have like the origin 0, 0, we will have like a point O, we will call pole, okay, like a point 0. And we will have that line, which could represent half of the x-axis, like the positive part of the x-axis, okay? But what this is not really the x-axis. We will probably do something like this. Yeah, but this is just because we have so much experience and we get used to X and Y, the Cartesian plane, that we can kind of see. But what we will do, we will indicate the points differently. Actually, the unit circle will be helpful because angles are involved in the polar coordinates. We will consider that positive part of the x-axis as a polar axis, and this will represent 0 degree. That's 0. The same like for the unit circle. And then we would like to indicate every single angle, like from 0 to 360, yeah, the full revolution. And the same notation, in order to indicate like 90, we will go counterclockwise direction, 90, 180, pi, 270, 3 pi over 2, and back to 360. Actually, I should put 2 pi. Okay, that means we like every single angle. Of course, I can say like 30 degrees, 45, 60, and so on. Yeah. Now, let's say that's my point, point A. What are the coordinates? We have to find out like what is the angle. That's important. That means let's call it theta. Looks like 45, but let's call that angle theta. Let me remove the other one. We know how to find out the angles. I mean, this angle is theta. And also we have to find out the distance, still the distance, but the distance from the O, point O, the origin, I can pull to that point. And I will assume that this is 1, 2, 3, 4, 5. Yeah, but I will go along that array, that angle. I mean, I can say this is 5 theta. Yeah? And 5 in general, we will call r. I mean, r is the distance from the pole and theta is the corresponding angle. Okay? And now we can see we don't have to go like with the straight lines. We can go like angle by angle. Everything will be more like, especially when we have the curves that are more like curvy or like some nice shapes. Actually, some of the polar curves are so beautiful, some flowers, some, because it's much easier to get the formula, the polar formula, polar equation. Okay. And I found this, you probably saw this before. Let's look at this, but that's of course, that's for fun. The polar bear is a polar bear, but Cartesian bear, yeah, that's just, yeah, basically like the straight lines. No. We can nicely get a beautiful equation for the lots of curve, which sometimes, I mean, most of the time, the curve are not even the function. Because even for the Cartesian equation, we can still get an equation that is not a function. But if it's too complicated, it's challenge to get the formula, the equation. But for the polar equation will be easier. Okay, that's nice comparison. I saw once, but I didn't make like a screenshot. I didn't make a copy of the cars. Like we know, like all of the cars, like they have nice curve shape. But I think one of the Tesla truck, I don't remember the name, Cybertruck maybe. I don't know if you saw that. It's like a straight lines. Yeah, it's not nice and curvy shape. It's a Cybertruck? Yes. Okay. Thank you, Charity. I didn't remember. I still don't know. And probably it's still not driving on the streets. It's yeah, but I saw like, yeah, I think it was Cybertruck. Yeah, if you can Google, you can see like a straight lines. I think probably the Cartesian equation will be easy to find for the edges. Yeah, but for the recent cars, the current cars, the polar equations. Okay, just a little bit of idea, but let's come back. Let's actually see everything properly. Oh, okay. That means for the polar coordinates, we will need a pole, which is the origin, and we will need half of the line. Yeah, that's we know this, and we will call the polar axis, and that's actually this. Polar axis, pole, O, we can call O, and a certain angle going counterclockwise direction, that's the positive notation, that's the theta, and distance from O, from the origin. Oh, I say origin, we can still say origin, pole. Yeah? And that will be the coordinates. We need that distance and we need the corresponding angle. Okay. And as I said, we may kind of always picture that, yeah, we have, because that's kind of like a full revolution, but I will not put the notation. I shouldn't even put X. It is kind of like an X, but we don't need X. I can say 0 degree, 90, 180, 270, and back to 360, 2 pi. I can do this, but not that. Okay, that means, for instance, if I would like to find the point, let's say 2, 3 pi over 4. Yeah, we can find this point because we have to know how to plot the points. Okay, that's 3 times 45. I think it's that angle. Yeah, that will be 3 times 45, and 2, I mean, at the moment, we don't know 1, 2. Let's say that's the units 1, 2. Okay, that means this is the point. 2 units from the pole on the angle 135, which is 3 pi over 4. Okay, that's the point. This is the point. Okay, and then we can plot any other points. But let's look at a few characteristics. Counterclockwise, of course, that's the positive. We can also use the negative notation. Yes, we can use the negative notation, but then we will go clockwise. It's the same like for the unit circle. That means nothing new. Yeah, let's try. For instance, let's name it point maybe C, and I would like also distance 2 on negative pi over 4. Yeah, that's when we can also find this point. Distance 2 on negative pi over 4. The negative pi over 4 will be that distance. I mean that angle. Yeah, this is the angle. And 2, 1, 2. 1, 2. That means this is point C, that big red dot. Okay, on that angle, I think that's the point C. Of course, if the distance is 0, it's just the pole origin. Okay. Now, we will definitely have positive and negative angles. We know what to do, counterclockwise or clockwise, respectively. We can also add negative notation for the distance. Okay, but how we will indicate this? Let's look at this one. When the quantity r, the distance from the origin, is defined through the negative number, then one important like characteristic, if r is negative, the point will be always plot in the opposite quadrant to the given angle. Okay, and opposite, like mathematically, means that we will turn 180. Like you probably know opposite. When I'm looking in front and somebody will say turn 180, it will be directly behind me, opposite my view. That means adding 180 degrees, adding pi, that's the opposite. Practically, please answer this question. For all of the angles in the first quadrant, which quadrant is the opposite one? Which quadrant will be opposite for the first quadrant? If I use my unit circle notation, the third one, of course, the third one will be opposite. Okay, for the second quadrant, all of the angles from the second quadrant, the fourth one. Yeah. And the other way works the same. For the third one is the first one, and for the fourth one will be the second one. Yeah. So when we have a negative r, and the angle is, for instance, from the second quadrant, we know that we will plot the point in the fourth quadrant, the opposite. Yeah. Explicitly, mathematically, is we simply adding to the angle 180, but adding 180 to each of these angles, yeah, that we make that pair, 1/3, 2nd, 4th. Okay, that means that's the only thing. And let's maybe plot like a couple of points. Let's take a point. Let's take a point just here, 2 pi over 4. Let's take a point 2 negative pi over 4. And let's take a point -2. Okay, that will be interesting. 1, 2, 3, 4, 5 pi over 4, because this will also give us some other concept. Okay, the first point, 2 pi over 4. In which quadrant we have to plot point A? Point A. Actually, I can call it that 45. Let's say this is pi over 4. First quadrant, because that's the angle, and I can also say 1, 2. Actually, this is that point A. Yeah, I'm just using. Okay, 2 pi over 4. I mean, this is. I don't even have to put this units. We know that if I decided to go by that amount, this is A. Okay, now B. In which quadrant we will plot point B? 2 negative pi over 4. The positive R, that means the same quadrant as the given angle. Given angle is here, negative pi over 4, and 1, 2. This is point B. Perfect. 2 negative pi over 4. Excellent. Okay, now it's interesting where we will plot point C. Point C. Who can tell me? First of all, let's find the angle, the given one, the provided one, 5 pi over 4. 5 times 45. In which quadrant? In which quadrant is 5 pi over 4? It's the third one. I think it's this one. Okay. I mean, this one is, let's remove this for now. This one is 5 pi over 4. That's the angle. Okay. But now I will not plot the point. I will not say 1, 2. Yeah. And point C, that will be not point C. I have to actually make that line longer, which means I'm adding 180, yeah, it's the other way. And I will plot the point on that line. I will plot that distance on the opposite. I mean, instead of using this one, no, because that will be positive too. If this will be positive. Now I will make this line longer on the opposite quadrant, yeah, which means I'm actually going this way. I add pi, or actually this way is more appropriate with respect to the arithmetic. Yes, we can just make the line longer. And then 1, 2, this will be the same point as A. Point C is the same point. So we may also notice that we may have 1 point, for instance, on the polar curve, and we may have a couple of multiple coordinates, which will represent the same point. And we have 2 reasons, because we know that angles, like we have from 0 to 360, and then we can repeat again. And repeat again is just like a circle, like a trigonometric curves, like sine and cosine, for instance, are also like periodic. Because I can say this angle is 45, or 45 plus 360, 45 plus another 360, 45 plus another 360. So I mean, I can infinitely many representation of that angle we can use if we don't make any restriction. Or I can use angle from the third quadrant and put negative in front of the R. Then I have infinitely many representation for 5 pi over 4, and then negative distance will be placed on that. So we can see we can have, exactly the same as A. Then we can have infinitely many. That means this is one different thing. I don't want to say weird, but different thing than Cartesian coordinates, because for the Cartesian coordinates, we have 1 dot and 1 coordinates per X and Y. No different X and Y will give us the same point, the same dot. Yes, but this one we may have infinitely many. Okay. I mean now, okay. I have this positive, negative, opposite. We okay with this? Let's look at, can That means I have here, let's try to find these points. Yeah, let's try to plot these points. A, B, C, and D. We can quickly check. And then I would like to also add something. Okay, A. I can, you see, I'm drawing X, Y. But that's how you will probably see the polar 2 pi. Okay, that's mean 1, 5 pi over 4. Okay, where is the angle 5 pi over 4? Oh, we had this one. I think the 45 is a good angle. 5 pi over 4 goes the third quadrant. Yes, this will be the third quadrant. That means this is the angle. And distance 1, let's pretend that this is distance 1. Okay, and this one is 5 pi over 4. That means this will be 1, 5 pi over 4. But I have to put A. Oh, I can do the same way. Okay, so we can see. Nothing is, I mean, the R, the distance from the pole is not negative. The point will be plotted in the same quadrant. Okay, let's do B. What about B? Where shall I plot B? I will still indicate the angles, yeah, because we have to know that we are in polar plane. Okay, 3 pi, we have to find the ray that represents the angle. 3 pi and then 2 units from the center, from the 0, 0, from the pole. Where is 3 pi actually? That's 2 pi and 1 pi more. It means it's the same as that part. Okay, and then 1, 2. This is point B. A, B, C, and D. Yeah, it's fun, and it's 2, 3 pi. Because normally we will say -2, but no. This is 2, 3 pi. Okay. A, B, C, D. Let me add point E. What about -2, 3 pi? Please tell me, where shall we plot the point E? -2, 3 pi. What is the opposite angle to 3 pi? Opposite angle to 3 pi? Directly opposite. It will be the polar axis, yeah? That means this will be 1, 2, and this point is -2. 3 pi, but -2. I mean, that's the point E. Yeah. Okay, what about point C? Actually, I can use 1. What about C? 0, 90, 180, 270, 360. Maybe I can use different color, green. -2 pi over 3. In which quadrant I can place that angle? -2 pi over 3. -120. Third one, yes. I think this is that angle, yes. And 2 units, +1, 2. This will be the point C. 2, -2 pi over 3. Okay, what about D? Okay, D has negative distance. Okay. Okay, everybody is trying to answer my question. In which quadrant we will plot point D? In which quadrant? -3, 3 pi over 4. Yeah, it's negative distance. No, okay, I think, okay, in which quadrant is 3 pi over 4? Second. Yeah, that's correct, because it's 3 pi, it's that angle. Okay, I can maybe remove that description. And I can put 3 pi over 4. However, 1, 2, 3. That's not good. Yeah, this will be not the point D, because we have to go to the opposite quadrant. Just make it longer. 180, 1, 2, 3. This point is -3, 3 pi over 4. Okay, that's in the negative will place in the, that's good, that's good. Okay, that means that's the point D, not this one. Okay, I mean, I hope we know how to plot the points. Now, what I would like to do, yeah, we have the solution. Oh, that's me. That's what we said. We know that each point will have many representation, but just not going like keeping the angles just between 0 and 2 pi. That's what we usually do. Yeah, let's check something. Let's say theta is only between 0 and 2 pi. I mean, what we will have? Do I have this? No. Okay, let's maybe do this. 0, 90, 180, 270, 360. Okay, and for instance, let's find the point. Maybe 30 degrees. 1, 2, 3, 4. Okay, I mean, this is point A. Oh, no, it's okay, point A. And then the coordinates of the point A are 1, 2, 3, 4, distance 4, and pi over 6. 30 degrees is pi over 6. Okay, but now I would like, yes, everybody can think. I would like another free representation of this point, yeah, of the same point, just different representation, different coordinates, but still keeping the angle between 0 and 2 pi. Oh, actually, let me, because I wanted negative. Let's say from negative 2 pi to positive 2 pi. I know looks weird, but I just want to use the positive notation from 0 to 2 pi and from 0 through the negative. Okay, that means let's just use this. We will not go like further, like 4 pi, 3 pi. No, but just using this notation, all of the positive notation between 0 and full revolution, and between 0 and negative full revolution. Yeah, 2 pi. Okay, that means this is the first. Using the positive angle, I can even say that's the angle. Okay, how can we find out, okay, the same point using possibly negative angle? Negative angle. Yeah, what is the negative? What will be the angle which actually I can draw that angle this way? Who can tell us if I would like to indicate that angle using the negative notation? This is 30 degrees. So you can just subtract 30. Pi over 6. Oh, nobody? No, you can. This is negative 90. This is negative 180. This one is negative, and this one I can say this is also negative pi. Yes, this will be negative 330, of course, because if this is 30, that angle will be negative. And negative 330 is how many times 30? 30 times what to get 330? 11? Oh, 11 times pi over 6. Yeah, that's, of course, that's the unit circle. Oh, my dog, I'm sorry. Okay. Okay, that's mean 11. I can also say that point A can be defined as a 11 pi over 6. Okay, 11 pi over 6 or pi. Oh. Okay, that's we do have 4 pi over 6, 4, 11 pi over 6. Okay, that's what I, hang on, negative, right? Negative. I wanted negative. Where is that? Negative 11 pi over 6. Okay, now I would like okay, I would like to indicate the same blue dot, the same point A, using the negative r, negative distance. It means I would like to have negative 4, and actually one more with negative. Because you can see what we have. We have 2 positive distance, positive angle, negative angle. Now we can have negative distance with the positive angle and negative angle. But what is the correct angle if we still want to plot the points in the first quadrant and having a negative notation? Okay, let me remove this. Yeah, okay, I'm talking and you thinking, that's really good. Okay, that's mean negative 4, correct. I have to be in the opposite quadrant. That's the opposite. Because it will be 1, 2, 3, 4. That's not good because we will plot that point in the opposite part. But we need that angle. That angle will be 7. I mean 210, which is 7 times 30, 7 times pi over 6. Really good. 7 times pi over 6. Yeah, that's the 200, that's the third quadrant, but we will plot still the point A here. Okay, now what about the negative notation? What about that angle, the green one, and also keeping negative 4? What is the green angle? Please tell me. The green one is yeah, it's like a unit, it's the same like the unit circle, but using the negative. The green angle will be on. Nobody wants to help Jared. You can just count. Yeah, it's going by 30. 1, 2, 3, 4, 5. 5 times 30. 5 times pi over 6, but negative. Yeah. That's the good. It's 1 times 2, 3 times 30, 90. And then 1 times, I mean 1, 2, 3. 1, 2, 3, 1, 2, 3. But we just reaching this one. That's we have 5 times 30, which is 150, but we using radians pi over 6. But it's negative because we went clockwise direction. I mean, yeah, clockwise direction. Okay, that's my point is that you can see we have one point, one blue dot, right? Because we have to be confident with this one blue dot, and then we have 1, 2, 3, 4. I mean, 4 different representation. We may still keep adding 2 pi plus 2 pi plus 2 pi, but I wanted to keep in that range just the full revolution back and forth. Okay. Okay, let's keep moving. That's the same thing. All of these points are the same. All of these coordinates are the same point. Okay, now what we will try. One of the important thing is to find the connection, okay, between the polar and Cartesian. So what I did, I put just the first quadrant, but we have to kind of look through the 2 coordinates, x and y, no problem. perpendicular distances. And then r and theta. R is the blue distance, the distance from the origin, and the angle, because the blue array, it has a certain angle. We know how to measure the angle, theta, from the zero, from the positive part of the x-axis. Okay, and then we have a beautiful right triangle. Okay, what we will need? We will need 4 equations. Yeah, I want from you, because I would like to connect xy with r theta. Okay, we can use anything, any theorems, any relation. Looking at this right triangle, what relation you can give me? Please give me any equation using x, y, theta, and r. Yeah, you can just using this right triangle. I think all of them, all of the equations we will get from that right triangle. Okay, any theorem, anything. Who can give us the equation? Oh, yes, for instance, we may have Pythagorean. That's really good. I think I type it, but I will write it. X squared plus y squared equals to r squared. Look how nice. If we have a point in the x, y, in the Cartesian coordinate, when we have x and y, we can compute r. Yeah, nice connection. Okay. Another, we have to also, that's important, that's nice equation. We also have to involve theta, because having x and y, how can we compute theta, for instance? Or having theta and r, how we can compute x or y? Yeah? Involving, probably we have to do, yes, we have to do the trigonometric functions. Okay, everybody is thinking, what trigonometric function will connect x, y, r, and theta? And I will write down. I'm waiting for you to give me the equation. No? Oh, no. You have to give me something. Come on, you can, first of all, you can check these slides on Canvas. Second of all, you have a Dr. Google available. Or which the first of fair, then you can just find out. Yeah. Okay. Everybody can think. Everybody, you can find everything these days. You don't need textbooks. You have the knowledge to remember. It's just your phone, anything, a little screen, and your and how do we call this line? Yeah, and the tip of our finger. Let's don't use anatomy. Okay, I like this one. Sine theta, let me write this. Sine theta will be defined as a y over r. And what I will do, I will say that y can be, actually I can say here, y can be computed r times sine theta. Perfect. If we have r and theta, we can compute y. What about x? How can we compute the x coordinate? What trigonometric function we will involve? Of course, cosine, because cosine theta is adjacent over hypotenuse, r times cosine theta. That's 2 equations that are extremely important. Because when we have r theta, when we have polar coordinates, then we can get Cartesian coordinates quickly. Okay, but we also need 1 extra equation, how to get theta if the x and y is provided. That we will need this to convert one way, and we will need 1 extra to convert the other way. If x and y is given, what trigonometric function? Yes, I think this will be helpful. tangent theta will be y over x. As soon as we have tangent theta, we can find theta. Yes, okay, that's the 4 equations that we must know. You may put them on your little formulas page. Okay, we have to know them. And we can probably create different things, but that's the thing, that's the equation. Okay, let's keep working. Oh, I have them. I have them the other way. Okay, that's me. Now let's convert. Let's convert the point to pi over 3 from polar to Cartesian. Okay. First of all, we may draw it just to know where we are. 60 degrees, 1, 2. Okay. It means we are here. That's the point 2 pi over 3. But I can maybe use different color. We would like to find the corresponding x and y. Okay. Okay, I will put x and y, but it's always weird to combine this. And that's actually exactly in the middle. Okay, how can we compute x? Who remembers the formula? We have to know them. Yes, we have to know them, or you have to know them that you have them on your notes. That's always okay. We can put r cosine theta to cosine pi over 3. Oh, what's cosine of 60 degrees? Cosine of 60? Jared, you have to earn some extra credit for representing the classroom every day. Yes, because oh, okay. Yes, 1/2, the x coordinate is 1. I think makes sense. This will be 1. Okay, what about the y? Who can type the formula for y? Similar to x. R times sine theta. 2 times sine of 60. And the unit circle, what's the sine of 60 degrees? Square root of 3. Yes, square root of 3 over 2, square root of 3. And this one I think makes sense. Square root of 3 is a little bit more. I mean, 1.8, more than 1. Okay, that means this is the way. And actually, this way, converting from polar to Cartesian is, I would say, a little bit easier because the output, the Cartesian coordinates, is only one pair. The other way, we know that we have multiple, like infinitely many polar representation of one point. Let's try. Let's just convert this simple point 1, -1, which is that's Cartesian. Let's get the polar coordinates. Yeah, then we have to, okay, 1, -1, I think it's this one. It is 1, -1, yes. Okay, so I mean what we will need? We will need that distance. Yes, how far is, and we will need that angle. Theta, negative, positive, we can see, we will have a couple of options. Okay, I can do this way. Okay. That means, first of all, how we can compute R. What equation we will use? Yeah, we will use the other pair. R squared is x squared plus y squared. 1 squared plus negative. 1 plus 1, 2. And now we can see we have positive or negative square root of 2. Okay, that means this point, I can even, let's say point P, can have positive square root of 2 notation or negative. We know, consequently, what this means for the angle. And now we have to find the angles. Okay, how we can find the angle? What equation we will use? This one was to find the r, distance, radius, we can call it. Who can tell us the equation? Oh, nobody? No, you can tell me. What was the equation? Oh, okay, arctangent. But let's say tangent, but yeah, that's perfect because theta is arctangent of y over x. Then tangent theta will be -1/1. Tangent theta is -1. That means theta, yeah, but I can just keep it this way. For what angle tangent is -1? Or maybe just to simplify it first, because then we can do the reference angle. But for what angle tangent is equal to 1? Then we will know what is the reference angle. If we know what is the reference angle, the distance from the x-axis is the same in each quadrant, pi/4. I can write for here, but this is, yes, 45. So we know that reference angle is 45. Then now we're looking where we are. We are actually in the 4th quadrant. We can say negative pi/4. Can we say negative pi/4? Definitely. But that's not everything. I can put negative pi/4. What about the positive? I mean, this is correct. This is definitely correct. We have to add few things, but this is definitely correct. But now let's say I would like to use the positive notation. I would like to indicate this angle using positive 7 pi, really good. And it's still the same quadrant because nothing is specified here. Nothing is specified. What about if I will use negative r? Then I will need that angle. I have to add pi. What is this angle? 3 pi/4 when we add pi to negative pi/, or I can use negative. It will be -7 pi/4. 7 or 1, 2, 3, 5. Wrong. 5. Yes, 5 because 5 pi. Okay, that means I can put 3 pi/4, or I can put negative, again, -5 pi/4. Each of these representation represents the coordinates of that point. Let's say P. Okay. And P, of course, is +1, -1. Yeah. So we can see that, and because nothing is specified, one of these answers is, I mean, all of them are correct, but you may pick one and provide this one. Or we may keep adding 2 pi, 2 pi, 2 pi, or -2 pi, -2 pi, the same thing. Okay, but at least this one are in that range of the full revolution. Okay, that's in, please, yeah, always remember. Because when we using arc, I didn't want to use the arctangent, because when we using arctangent, yeah, then arctangent has a certain domain. Yeah, but yeah, I will not go beyond. We will touch this a little bit tomorrow. But not using the arctangent, still applying the inverse trigonometric, then we can have any representation. Okay, any notation of the angle. Okay, do we have time for one thing? Okay, yeah, I just plotted this. I mean, I just calculated these two. Yes, we have to be careful with this one. Okay, let's just, yeah, we have 5 minutes and we will do this tomorrow. But just maybe to finish the session with one polar curve. Because now, since we know how to plot the points, how to convert, we will never make the mistake with plotting the points. We would like to get not only the points, the collection of points, the curve, the polar curve. And the same like we did have for like y is a function of x, then we will have r is a function of theta. Yeah, because angle will be the independent variable. Or sometimes we also notating the function f of x y equals to, but that's a little bit different maybe for multi like variable, but yeah, we can also have this notation. But definitely r depends on theta. Okay, and we may have a couple of equations, and we also have to know how to plot them. We will not go so crazy. No, just a basic one. But before we finish the session today, let's plot this equation, and this will be the last one. And actually, this is a proper polar plane. Yeah, that's the proper polar plane, which I usually will still do the XY kind of, because this is, yeah, that's the all of the angles, and now we can find the distance. Okay, what curve is represented by the polar equation r equals to 2? Looks like a constant, yes, in one way, because r doesn't depend on theta. What do you think? What is this equation? If you can tell me, I can let you go. It's a circle. I think it's a circle because r, the radius is 2. Doesn't really matter what is the angle. It's just 2 for every single angle. Let's maybe say this is 2. Yeah, distance 2, and for 1 degree is 2, for all of these degrees, for 90 is 2, for 180 is 2, for everything. If I will draw every single angle, I will indicate 2, 2, 2, 2, 2, 2, 2, and the connection of this, of course, is a circle, because just the radius. Now, what is the Cartesian equation for this? Because that will be your question on the test. Oh, no. Do you remember the 4 equations today? Did you put them down on your reference page? One of them will work. X squared plus y squared is r squared. X squared plus y squared is 4. That's, yeah. This equation is equivalent to this polar equation. Cartesian equation, polar equation.